Hello, hi. So this video about the transformer, the little bit of knowledge I want to give you about transformer, different type of transformer, high frequency, low frequency, and their materials. So you can see in the screen there are different type of core materials I have placed here. So initially, at the beginning of research, there will be the lots of, you can see the adapter or charging device. You will see that heavy one there uses this 50 hertz transformer. So 50 hertz transformer is used, and then they use bridge rectifier to rectify that transformer for step down the 230 volt AC, and then bridge rectifier converted into the DC to get the 5 volt output or 12 volt output. So 50H transformer is heavy in size. Their core are uses laminated to reduce the eddy current losses. So such type of core are used. These core are in slice to reduces the eddy current losses, and laminated one. This core is single type E and I type. This is I. This is I type, and if you open it this side, you will get a E form. So such a number of plates are connected to form that whole core, and using this plastic bobbin wounded the coil. So at high power case, the primary and secondary, the which one is the higher voltage, that kept nearer to the, for low voltage, whichever the primary and secondary, if primary is low voltage, they kept nearer to the core, as because it's read lower insulation. Higher, for higher voltage, it is kept outside side. So this is 50 years. Then research go ahead and developed some material is high frequency. The overall thing is compacted one. So this high frequency one is this one. You can see this is uses a ferrite core. Same type, there will be a bobbin, and this material is different because if you have 50 hertz using iron core, but here we are using iron oxide core, ferrite, nickel manganese or zinc manganese core. High frequency, because at frequency increases, your eddy current hysteresis loss will be increases. If you 50 hertz core used for high frequency, it will be melt down. So there these materials for high frequency, this is E type, and then there are some other core are toroid core are available. This is also ferrite core, the bigger size and smaller size. So one advantage is toroid core, there is no air gap, so it has a higher efficiency. But if you go for high power application, so you need a large inductor according to the your converter circuit, design of converter circuit for CCM operation or DCM operation. So then you have to provide a air gap to get the desired induction. At that time you need such E type EI core. Then toroid core become flux density is such low that can saturate the core, so you need that time needs this EI core. So this is a high frequency core, and this is a low frequency core. The material is different, and a transformer, if you see the here, the common concept that magnetically coupled and electrically isolated, mainly used for step up step down the voltage. And there is another advantage is that it's provide a insulation from primary side to secondary side. If there is any secondary short circuit happen, there will be no effect in the primary side. And secondly, that transformer, in case of present adapter, you use mobile charger, it's smaller in size, that because of this high frequency transformer reduces the converter circuit so small, and also make it a lighter weight. Once you provide the supply to the primary, then there is a current flow, and using the right hand thumb rule. If it is direction of current, then flux will be indicated the thumb. So the flux will flow like this, and this flux is linked with this secondary coil, and then there will be a EMF induced. So then secondary you have to use right hand thumb rule. You will get the direction of current flux, your thumb, and this will be the your direction of current. So in this way you can find out the direction current from dot and cross convention. And if it is entering into the using dot, then it will leaving the dot, you have to put cross or you have to put dot here. This another in BTech level there will asked some question, if you construction wise or operation wise transformer and induction motor, you will say same principle, both are magnetically coupled, but induction motor rotate and transformer didn't rotate. Why? So it is because of its winding. Induction motor uses distributed winding, that is apart from 120 degree there you will get a rotating flux, but in transformer you will get a concentrated winding that is wound in a single leg. So that's why there is no rotating flux, otherwise transformer will also start rotating. So this question sometime in quiz asks. And other things is that in transformer beauty is that you use, there are lots of high frequency switching device now. Gallium nitride is discovered, so their frequency is order of megahertz. So that there are lots of material, as I have already told, manganese zinc and manganese nickel materials are used, but there are also powder iron core are available which has very low losses, core losses. Now question is that another question, now you have connected transformer, and once you connected, this coil resistance is very low, order of few milliohm, this coil resistance. Now you connected 230 volt. So if you thinking that the current flowing through this core is voltage divided by resistance, then is a huge large current will flow, then your fuse you will blow. So why this thing is not happen? Because if you simple way you will think, so that thing is that once you connect a transformer, as the flux is generating, so it is developing a back EMF here, so counter EMF that is called. So that counter EMF is oppose the current flow. So once you have the difference between two voltage, then that little amount of current flow. See, if there is no secondary load, you have don't connected any secondary load, so then primary does very minimum current. That current is here, it's magnetizing current, that is to maintain that flux or voltage. Once you keep on increasing the load, primary start drawing current. So if you see the flux line, so there is a one for primary, then if their current secondary current will flow, so then there will be another flux line, but direction of flux will be opposite, it will oppose the primary one. These two are opposite to each other, so due to this opposition, so there will be losses taken place, and the whatever the in demand of load current, the primary drawn current will increases, because primary have to nullify this opposition of flux, and then you need to provide the magnetizing flux or magnetizing current. Mainly transformer losses are hysteresis and eddy current loss. Hysteresis is because that you are using magnetic core, so there are dipoles are there, lots of. So dipole, once you flow the current, so dipole will align at the direction of one direction, and then there is AC is used, so there is a positive negative, so one direction is arranged, and then you supply direction is reverses, the dipole direction will be reverses. So there is a collision between these dipoles. So that's why you will, in transformer you will heard some hissing noise, and that is for hysteresis loss. And core will warm up for this. So using in cooling, air cooling is very cheaper one. Otherwise oil cooling are used, and different type of high insulating oil are used for transformer cooling. If you go for design of a transformer for high frequency transformer, so first, high frequency transformer generally used for different boost converter or buck converter mainly used, and there are forward, flyback, pull bridge average, such converter used. So first you have to find out that inductance value required inductance value, that is for primary. From that inductance value you have to calculate the peak flux density. So that peak flux density is very essential for choosing a core. From that peak flux density you will find the data sheet of different core. You choose that core that peak flux density should be lower. That means your required peak flux density and the core flux density should be higher. Core will be higher and your requirement will be lower. Otherwise core will be saturated. Saturated means if you BH curve you see BH curve, what happens such. So your flux density and field intensity, if core is saturated, if you increases current, if you increases input side power is increases but your core is saturated, there will be no increment of the power at output side will happen. There will be everything will be your loss is increases. It will not transfer the power from primary to secondary. Second is that there is a very big misconception in the student. So transformer is transferring the power from primary to secondary. So everyone thought that power is, everyone if you see that they will say transformer transform the power, they increases power or decreases power. That is very wrong statement. It only increases voltage or current. Power is always reduced because transformer efficiency 98-99%. Power never will be increased. Power either reduce, voltage will increase or decrease, and according to current will increase or decrease. So what I am talking about, if you have a code that is saturated one, your whatever your input voltage or current is so high that your core is saturated and you are keep on increasing input side power but you are not getting desired output power, so that means core is become saturated. So this thing is important. Once choose the core, you should see the data sheet. The peak flux density value of your core should be higher from your design requirement peak flux density. Second, in maximum core they have mentioned inductance factor. Inductance factor is a easier way to choose any core. So you have the required inductance value for design, and inductance factor is such that it is L by N square. N is the number of turns required to get that desired inductance value. That is A is equal to L by N square. That inductance factor value is written into the datasheet. Your desired inductance value you can put here. From that you can calculate this N value. So number of turns required to get that desired inductance value you will find out easily. So that things maximum code datasheet you will available inductance factor. This is called inductance factor. And you know that core is transformer core. There is a, if you design the basic model of transformer, equivalent circuit, primary side. So there is a core loss bunch, magnetizing core loss, and this is core loss, this is magnetizing, and this is primary winding. Then there is a secondary winding. These are magnetically coupled. So when there is no secondary side load, the whatever power is drawn from the input side, that is to for this magnetizing core and the core loss part. This primary side current is null because there is no secondary current. Once the secondary load and start flowing current, then the primary side current will flow. That whatever I've said the previously, this flux, to overcome this flux and to maintain that magnetizing flux, so it will draw start current. That's all. Thank you.